the last question, guys. So we're on example 8, and this one's completely different from the first 7 that we worked because we have two absolute value signs, right? So essentially, if this equation is found to be true or we find a solution, the inside of the absolute value bars, either on the left-hand side or the right-hand side, let's focus on the left-hand side though, should be equal to the positive version of what's inside over here and the negative version of what's inside of here, okay? So essentially, if you have two absolute value signs, essentially you can treat what's on the inside here like your A. Okay, so we are going to do the exact same thing that we did before. So we're going to take what's on the inside of this first absolute value and write it twice. 3x plus 2, 3x plus 2. And we're going to set it equal to the positive of A, which is the stuff on the inside. Okay, remember, because we're working with multiple parts, we need to use parentheses. Or the negative of A. Okay, so our A here is 5x minus 8. 5x minus 8. Okay, so now we just solve both of these separately and see what we get for x. To get rid of parentheses, first you check the power, then you distribute. So those parentheses right here will just drop. So we have 3 plus 2 is equal to 5x minus 8. When your x's are raised to different powers, you want to set it equal to 0. These x's are the same power, so we want to get them on the same side. We can either subtract 5x or we can subtract 3x. I'm assuming you guys will put the x on the left-hand side, so I'm going to subtract the 5x. Okay, so if we subtract the 5x, that's going to get rid of this. Right, and now we need to move this 2 to the other side, so that means we are going to subtract the 2 on both sides. And now these 2 will cancel. And that leaves us with 3 minus 5, so we get negative 2x is equal to negative 8 minus 2 is negative 10. And then this negative 2 is connected to the x by multiplication, so to reverse it, we divide both sides, and we get x is equal to positive 5. Okay, or now we can solve this other side. So we do the same thing. So to get rid of parentheses, we check our power, then we distribute. Remember, this negative is going to go to all of our parts. Pluses and minuses separate your parts. So we have 5x and the negative 8. So here we'll get negative 5x plus 8. And again, your x's are the same power, so you want them on the same side. So I'm going to add this 5x because it's negative. I need to do the opposite. So once I add the 5x, this is going to cancel. And now our x's are on this side, which means I need to move this 2. So I'm going to subtract the 2 on both sides. And once I do that, these 2's will cancel and we're left with the number on the other side. Okay, so here we get 3 and 5 gives us 8x equal to 8 minus 2 is going to give us 6. Connected by multiplication, to reverse, we divide both sides. So we get x is equal to 6 over 8. Remember, whenever we're simplifying, we see what the top and the bottom both can be divided by. And we can divide the top and bottom both by 2. So if we divide the top and bottom by 2, that's going to give us a 3 on the top and a 4 on the bottom, okay? So right now, these are our possible answers. This problem is a little bit more complicated because they have the absolute value bars here. So it's imperative that you go back and check your answers because it might not always work, okay? So I'm going to take a second and write down this stuff so we can plug in our values. Let me see. So we have, so when we're checking, we're going to go back to our basic problem. And we are going to check for both of our answers. For x, give me 1 second, just writing it down. So for x, we got 5 and we got 3 over 4. Alrighty, so this is what we're working with. So to be able to check these solutions, essentially we are literally just going to plug it in and see what we get. So for the first one, we want to know if this is true, so I'm just going to put a question mark here, okay? So we can do 5 first. So essentially all I'm going to do is plug in 5 instead of an x and see if it works out. Oops, let me put the 5 in there. Plus 2, we want to know if this is true. Absolute value 5, negative 8. Okay, so here it's going to give us 15 plus 2. I want to know if it's true. 5 times 5 is 25 minus, oh, that's the absolute value. Fine, sorry, it kind of looks like a parentheses. Okay, and then here we get 15 plus 2. It's going to give us the absolute value of 17. And then over here, 25 minus 8. If we do minus 5, that gives us 20, and then minus 3 more would give us 17. So does the absolute value of 7 equal the absolute value of 17? Sorry, 17 equal the absolute value of 17? Yeah, because the absolute value, all it does is changes everything to positive on the inside, or whatever that number is on the inside to positive. So 5 works out. So now we need to do the same thing for 3 over 4. So let's check to see if it works. So we go back to our original problem, and instead of x, we're going to write 3 over 4, and then we're just going to see if this actually worked. And whenever you plug in, you should always use parentheses. 3 over 4, 3 over 4, and our goal is to see if this is true, okay? So right here, whenever you have a fraction times a fraction, remember that you can multiply straight across on the top and straight across on the bottom. I would just make everything a fraction. So this 3 right here is the same thing as 3 over 1 times 3 over 4, right? So it's going to be 3 times 3, which is 9 over 4, okay? So in this first slot, we have 9 over 4 plus 2 equals question mark. And then in this next slot, we can do the exact same thing. So this 5 needs to be a fraction, so we put it over 1, and now we're multiplying it by 3 over 4, so we multiply straight across on the top, which gives us 15, and straight across on the bottom, which gives us 4, okay? So this is equal to the absolute value of 15 over 4 minus 8. Alrighty, so we need to combine these together and see if it actually works out. Okay, so let us see. So we're trying to add fractions. To be able to add fractions, you need to have common denominators again. So we need to change this 2 to a fraction. So instead of 2, we're going to say 2 over 1, right? And same thing over here. Instead of negative 8, we're going to say negative 8 over 1. And now, to be able to make the denominators the same, this one's a 4 and this one's a 1, we need to multiply the top and bottom here by 4. This one's a 4 and this is a 1, so we need to multiply top and bottom here by 4. Our goal is to make the denominators the same, okay? So, once you have similar denominators, you just take all of this top portion plus the sign and put all that together. So we have 9 plus 2 times 4 is 8. And then we're dividing that by our common denominator, which is just 4, okay? We still have the absolute value. We want to know if this is equal. And then over here, we have our 4 on the bottom, so we take our top stuff. Okay, so we have 15 on the top minus 8 times 4, so we have 8 times 2 is 16, and then we have 32. And then that's going to be divided by 4. Alrighty, so we keep going. Okay, if we add this 9 and 8 together, we get 17 over 4. And we would have the absolute values there, but remember, all the absolute values do is make it positive, so that's actually just going to go away. I'm just erasing it now because I don't have any more space left over. And now let's see if it actually equals the other side. So we have 15 minus 32, which would give us what? 17, right? Well, it's going to give us negative 17. So we have negative 17, and that's going to be divided by 4. Remember, we have our absolute value signs here because of these. And all the absolute value signs do is get rid of the negative, so I'm going to take this negative off. And they do equal, so this one checked out also. So both 5 and 3/4 are the correct answers.